Okay, I just started recording. It will take a moment. Okay, so it started recording. All right. So I hope you guys got a chance to look at the tutorial and also listen to the lectures that are posted this week. So this tutorial is also very straightforward. Slightly difficult than the last week's tutorial because in this one, essentially, in the first question, you already have access to the code, right? Whichever I have posted. We kind of looked at two different varieties, right? One is using critical sections, and then other one is using parallel for, right? So I guess the parallel for code is not complete, but the critical section code was complete in the lectures. So what I would like you to do is basically kind of complete the parallel for program, and then all you have to do is basically essentially replace this function, right? I think we had 1 plus sin x in the lectures. You just have to make it sin x by 2x cube, and then the limits of integration are now 1 to pi, okay, instead of 0 to pi. And then, of course, there is an analytical solution which you can find in the for this integral, and then that is given here. So this is the exact value, I equals 0.198573. So I would like you to kind of make 32 trapezoids and then run this with 2, 4, and 8 threads or codes, and then see that you're getting a correct answer with all these things. That is the first part, and then of course the second part is basically run the same function with the implementation that has parallel for. Okay, so once you do this, you would basically convince yourself that the parallel codes kind of produce correct results. At the moment, we are not looking for any efficiency as such. We will come to that later. As of now, we are just looking at producing correct results with any number of threads. Okay. All right. Okay. Then. Okay, then the third question is slightly involved. It's not very difficult. So basically, in the trapezoidal rule, we basically make use of a straight line. So instead of that, if you have a parabola, what you get is Simpson's rule. I think you are all aware of that. So when you apply Simpson's rule, you can derive the final expression for the numerical integration to be equal to h by third times h by 3 times f naught plus fn. These are like your a and f of a and f of b. Plus you have, for all the odd numbers, you have 4 times a summation of the fj's, and then for the even numbers you have 2 times the fj's. Okay, so that's where there is a small difference when it comes to Simpson's rule compared to the trapezoidal rule, right? Because in the trapezoidal rule you don't differentiate between even and odd. All the interior points you get basically 2 times the contribution or so, right, depending on the factor in the front. Now all you have to do is basically modify the numerical integration code that was given for parallel for, okay, and then evaluate equation 1. Essentially, this is the same function. You would do it, and then again use the same number of trapezoids, 32, as well as the number of processes, 2, 4, 8. Okay, and then this is where you would have to see that the error that you would get is much smaller with the Simpson's rule when compared to the trapezoidal rule. So you would use the exact solution as the reference. Okay, so that is that's kind of a short tutorial, which I hope you'll be able to do. Fine. I hope you also probably were able to do the first tutorial, right? Which we didn't as such discuss. I think I kind of gone through it in the first lecture, but it was straightforward because most of the code was there. Only the third one is where you have to kind of plot the time versus as a function of n, the size of the matrix. I hope you are able to do that as well. Let us see. I think that's all I have as of now. I would like to kind of answer any questions or discuss or clarify any points that you may have. Or anything on the lectures. You can either unmute yourself and ask the questions, or you can even type it in the chat box.
Sir, I have a doubt regarding the course, the concept of course.
The concept of course, okay.
So is it like each core can only run one process at a time, as in one thread at a time?
I think even it can run more threads as well. If you enable hyper-threading.
But is there a limit of like only 1 or 2 cores at a time? Or
The thing is, if you it kind of depends on the architecture of the the processor and the codes. Usually you can run, I think, depending on that, you will be able to run either 2 threads or 4 threads and things like that. But I don't think there will be a limit. You can even run more, but it will be a kind of performance penalty. It will basically, the same core will be acting like doing one after the other. So it will just
Okay.
slow down the performance. I guess maybe Professor Rupesh can add if I'm not.
No, this is perfect.
This is fine. Okay, yeah.
Thank you, sir.
Yeah, thank you.
Sir, I have a doubt based on the lecture.
Okay.
So you mentioned that if there is a race condition, it will result in an uncertainty in the results, right?
Right.
For operations like repeated addition, it wouldn't matter, right? What order the threads get executed. If we are only going to
yeah, so the race condition only applies if so. What is a race condition? Race condition is where all the threads are competing for a shared resource.
Yeah.
So when we say shared resource, let's say we have an array, and it's not that the threads are competing to write to different elements of this array. They are all trying to write to one element. All of them want to write to just one element, and then this writing to one element is not straightforward. It's not like if you see there are several steps involved. Basically you have a variable value, then that value has to be sent to the kind of cache and then register and so on. So as a result, there is a chance for, if there is a race condition, there will be a chance for an error in terms of updating the value, because the value that is there in the register might be something different from the value that is available in the latest value in the variable, and there are also other steps involved. So as a result, if all the threads try to update a shared resource, then that will result in error. Okay, that is not guaranteed as such. It may still give a correct result, as we saw in the class when we tried to run it, but it is not guaranteed. So you don't want to run something that is not deterministic. So that's why when everybody tries to update a particular value or a shared resource, then we have to make sure that they get mutually exclusive access to that resource. Is that does it answer your question, or I don't know, maybe you can repeat your question?
Yes, sir, understood. So this is only a synchronization, like it's not synchronized here, right? So, or that is a different.
Yeah, it's kind of synchronization. Yeah, I mean, essentially everybody is kind of going in a queue, like one after the other they are updating. So synchronization is slightly different, isn't it? I mean, essentially synchronization is a little more generic word, right? Because for example, everybody has to wait for all of others to finish. That is also kind of a synchronization, right? So yeah, I mean, this is some form of synchronization, you can call it.
Okay.
Yeah.
Good evening, sir.
Yeah, good evening.
So I have more basic question. Like you mentioned the 3 terms, sir. Core, one is core, another is thread, and another is processor. So can you, sir, distinguish between them? How the hierarchy is there in between these terms?
Okay. So I think the processor and core are pretty much, you can say, are pretty much the same, and in as far as cores is concerned. So number of cores is probably same as the number of processors. Whereas threads is something that can be higher than, there can be multiple threads on a single core. That is what it is.
Okay.
So some terminology you can even say, let's say, there can be multiple cores on a processor as such. But I think in today's multi-threading, multi-core architecture, you would just say you have a, dual core processor, and then each core can have maybe 2 threads or 4 threads and things like that.
So core is higher hierarchy than the thread.
Oh, yeah. I think so. Yeah.
Thank you, sir.
Yeah, thank you.
So I want to add to the same question that was just asked. So
Yeah.
I checked my PC's processor details, and it showed that it has 4 cores and 8 I guess logical processors.
Okay. I believe that is basically called maybe the logical processor, maybe, kind of is referring to as threads, I guess.
Or maybe, sir, ALUs, the 8 ALUs units.
ALUs as well, yeah, okay.
Okay, yeah, okay. Yeah, logical processor.
Yeah.
Yeah, and
Yeah,
sir,
go ahead. Yeah, go ahead.
I wanted to ask about the actual basic difference between OMP parallel and OMP parallel for. I mean, when we write OMP parallel, we like pass on the whole function to different threads. But
Right.
when we write OMP parallel for, we pass only the for loop inside the function. Is it right?
So, okay, so basically OMP parallel for should have a for loop, should have a for loop that follows it, okay, immediately, right?
Yes, sir.
And now this for loop is what OpenMP will try to parallelize. For example, if this for loop has 100 elements and there are, let's say, 4 threads you are running, then essentially each of them hopefully will get 25 numbers. You are kind of looking at I equal to 1, I less than or equal to 100, I plus plus, something like this, okay? Then each of them will get 25. That means the work that they have to share is being again partitioned by the threads themselves, okay? Fine?
Okay, sir.
Now, okay, and I think you will be able to draw a parallel to our first lecture or something like that. Okay, just hang on. So basically, in OMP parallel, you don't have a for loop as such. You basically have what is known as what were we calling this thing?
Structured
As
block.
a structured block. Okay, a structured block is one where you have one entry and one exit. Okay, and now it is up to you to make. So that means this entire structured block will be executed by all the threads, right?
Yes, sir.
Yes, all the threads. So that means it is up to you to define, kind of assign different data to different threads. You remember we have done this local N, local.
Yeah, local A, local B.
Data parallelism and task parallelism. Can you relate to something like that? How does these two relate?
Yes, sir. Yes, sir.
Yeah. Does it answer
So
your question?
basically, like, why is OMP parallel for? I mean, is better than OMP parallel?
It's not better. I didn't say it is better. Only thing is that for certain applications, it could be readily easy to apply. That's all. See, for example, what was the code we looked at? We looked at the calculation of trapezoidal rule, right? Integration, isn't it? So
Yes,
if
sir.
you look at from a coding perspective, then we had done, we have introduced local A, local B, local N, all these things, as well as we tried to kind of fill what are these extents using, myRank, all those things, right? And we have done some additional variables and then try to fill them, right? We have to kind of update all those values and do, right? Whereas if you see for this problem, if you had used just a parallel for, you don't have to do all these things, right? Essentially, you could just use the original NAB, and then they will just split the data among themselves and then do the work, right? So that's all. So it's not that I'm not contesting that OpenMP parallel is better than OpenMP for. It's just that with OpenMP parallel for, whatever the the numerical integration we have looked at, it is much easier to code, and that's all. I think if you look at the performance, I think they probably will perform at the same speed. Okay, that's all. So, but in many cases, maybe let's say you don't have a for loop, you have to go with OpenMP parallel only. Okay, so OpenMP parallel will basically give you whatever is the structured block. It will give you access to number of threads that you ask for, right? And OpenMP parallel for is more specific in a sense. It not only will give you the number of threads, but it will also partition that for loop that follows it, right? So
Okay.
they're different. It depends on the application. You can write the code in either way. Okay.
Yes, sir. Thanks.
Yeah. So
Sir,
let's say, let me finish this thing. So let's say in the exam, I ask you, and then you would write with parallel or parallel for. You will get points for both. Okay.
Okay, sir. Thank you, sir.
But if we say specifically use parallel for, then you have to use parallel for, right?
Yes, sir.
Yeah. Okay.
Sir, can we use OMP parallel for inside the OMP parallel?
Yeah, you can. We will come to that little later. So essentially, it will not be like you will not write again parallel. You would say OMP for, that's all. So basically, this will come to that in a little while. So maybe in the coming lectures, I will discuss about this thing. You can do that. So that means what you are trying to do is you are trying to, let's say, let's talk about, let's say you have two for loops. Okay, you have for I equal to something, blah blah blah, and then inside this you have for j equal to something, and so on. Okay. Now let's say this outer loop goes for 100 iterations or 1000 iterations, and the inner one goes for 10 iterations or 100 iterations. Okay. Now let's say if you put in a hash pragma OMP parallel for here. Okay. Now what will happen in this case? When will the forking and joining will happen? So for each of the 1000, it has to do forking, and then once the for is done, it has to do joining, and then it'll open and close this thing, right?
Yeah.
So that is not very efficient. So in such cases, let's say you know that the number of threads you are going to use are the same. Okay, so essentially they are not changing. You would always use only, let's say you have, let's say 5 threads, you will only use those 5 threads. Then you can actually start the 5 threads here, and then you would say this will be my OMP for, that's all. So basically you will have a parallel section here. Okay, and below that you would use a OMP for here, which would, that means it will fork them here, and then you will use them here in this loop, right? Something like that you can do. We will discuss this thing in the coming lectures.
Okay, so outer for loop will be removed is what I understood. Like outer for loop will be removed, and for inner for loop we'll use Pragma OMP for.
I mean, essentially you already have a forking happening, but then these things are not. It is not wasting time in forking the threads and then joining them again and again.
Oh, okay.
We will come
Thanks.
to that in the coming lecture. Yeah, I think somebody will just ask some question here, maybe. Okay. Yeah, so Arito says, yeah, I mean, virtual, yeah, depends on the, so threads can be even, depending on the, as I said, course, they can be 2 threads that are given, but you can always make more threads using, hyper threading as such. Okay, I think somebody has written an answer. So thanks to Jayant. So logical cores are the number of physical cores times the number of threads, and on each core. Okay. Okay, fine. Fine. Okay, let's go back. Yeah. Other questions?
Yeah. Does it make a difference if we have the directive right before the call to the function versus if we have the directive within the function itself? So is there a difference between the two other than like the scope of the variables, whether they are shared or private?
Yeah, it should be. I mean, as you said rightly, it will have an effect on the scope of the variables, but otherwise it should be fine. It should be the same.
Okay.
Yeah. Only thing is that, for example, you can again relate to the function we have written. What did we write? We wrote this trapezoidal function, isn't it?
Yeah.
Trapezoidal rule. So in this one, we have put our call before the trapezoidal rule, isn't it?
Yeah, we did. Yes.
We did.
That's why
So
I asked if it can be put inside as well.
You can do that inside as well. Yeah. I mean, essentially, the forking is not happening here; it is happening inside this one. So, for example, let's say for the tutorial 2, if you had to do the the Pragma parallel for, right? For the parallel for, you can as well just do it inside this thing, because you don't have to change the structure of the code. You don't need to get rid of this trapezoidal rule and then write it in the main function and so on. You could just put it in here, and then that would do. Of course, you have to now get rid of all those local values and things like that. That should be the same. But
okay,
as we discussed, the behavior will be very different if you have a reduction variable, or if you we discussed in the day before yesterday's lecture. That this trapezoidal rule will also be, if let's say if you have a kind of critical section put in here, then this will also be made critical. It will also be done sequentially, so that will have a performance penalty.
So parallelizing the call to the function is not much difference than parallelizing the steps of the function itself.
Right.
So, other than the scope of variables that you mentioned.
Yeah. Yeah.
Okay.
Yeah. So even the function will have a scope. For example, if you put it, so the function will also be, will be known to all the threads if you put it outside. Otherwise, no. Yeah.
All right. Yeah. Thanks.
In its own table. Yeah.
Sir, can you explain this forking for parallel for with a simple example, sir? How it is forking and how we are putting the instruction like that?
No, and essentially, for example, let's say you have when you write a code, you have a master thread that is basically executing the calls, right? Although you're running with -f OpenMP, you have compiled it. Let's say you say /a.out or whatever with some 4 threads. Then the moment it sees this hash pragma OMP parallel for, this is the location where the master thread will create, right? If you ask for, let's say, total 4 threads, it will create 3 more threads, right?
Okay.
So this is where there is some overhead, okay, which we are, so there will be some overhead, of course, to create the extra threads, right? So there is some time that is consumed, which you haven't measured, okay? But there will be certainly, because there will be something, because where you have to load these threads, load their own, own stacks, and then also make all these variables shared, private, all those things. Then this is where essentially the forking happens. Okay. Now let's say if you have 4, so you have 4 of them. Now these guys will, if it is for it, they're going to kind of hopefully split this range. Let's say if it is 100 into 4 parts, right? So each will get maybe 25 or so, fine. Or if it is not divisible, the compiler will take care of it and then try to adjust them such that they are close to each other. Okay, so that will be done. Then each of these guys will, all the threads will execute in parallel. And then when this for loop ends, that is where there is there a implicit barrier here? When the for loop ends, will all of them wait or no?
No, they will join.
No, they will join, but will they wait or will they just go forward? They will join, and then only the master thread will terminate all the other threads. And then after this, again, the joining happens once everybody reaches, and then you would again go with a master thread. So essentially, only this part of the code is parallel, right?
Yeah.
And the next part is again serial. So depending on how many, let's say, so that is what I meant by you can incrementally make it parallel, right?
Okay.
So you can come, let's say, one day and say, okay, I'm making it parallel. And after 1 week, you can say, still I'm parallelizing the code and so on until you're done.
Okay. So the lines which are coming after that parallel first will be executed in parallels within the structured blocks.
Right. I mean, essentially, you need to look for these statements. Wherever you have this hash pragma OpenMP, that is the locations, hopefully, where there is a forking happening. Okay. And then it will end after this scope ends.
Okay. Okay.
Yeah.
Is the performance always proportional to the number of cores? Number of threads used, or is there a limit to, or is there a trade-off between?
Yeah, there is a trade-off. There is a trade-off. I mean, essentially, we will come to that in performance analysis, which will come in only after MPI, because that's where I have put it. So think of it this way. For example, you have, as I said, there is an overhead here, isn't it? There is an overhead here in creating the threads. So if you have 100 threads, there is some time spent in the overheads, and then also, in adding them sequentially and so on. So, for example, I think the discussion can be back to the lecture where we had, when we had used the critical section, without the reduction operator, we said that the call to the trapezoidal is also made critical, isn't it? So if you run it, for a sufficiently large number of threads or something, you will be able to see that this will actually be slower compared to the serial version, So in a sense, you can extend the same logic to having more and more threads. For example, let's say you have 100 elements in an array. and you can say, okay, I would use 100 cores, so but the performance with 100 cores must be poorer compared to performance with maybe, let's say, 15 cores or something. So now this is something is which we should actually know a priori, not posteriori, right? This is what something we should know a priori. But I would kind of keep this discussion until probably until we learn MPI, because that's where we end up with some kind of messages being sent and received. So I would like to introduce that concept before we go to performance analysis. So actually that's a good question, because the idea is now we would like to, let's say we are learning parallelization and we would like to parallelize our code, okay? But the question we should ask ourselves is it worth parallelizing, right? So,
Yeah, right,
well,
yeah.
certainly not all codes are worth parallelizing. You can actually, many of the codes that you have probably are can be run in serial, and then you can get the answers, okay? So this is what question we should ask. And if the answer is no, then we don't have to parallelize the code, Let's say your advisor says, okay, just parallelize the code, then you can say, look, I have done a performance analysis, and this particular metric shows that the parallel performance is poor compared to the serial one, so we don't have to parallelize it. Then that means both of you save a lot of time, and you can spend time on something else, on a improving the better version of the code or something else. So so there are several metrics. We will come to that. So there is a law as well. It's called Amdahl's law, and other things which we will several other metrics are there, which all of them have certain restrictions in terms of what overheads they consider and what times they consider and things like that. With that, we will be able to kind of come up with some value for any code on what will be the some kind of a maximum possible performance that you can get. We will ask questions like this: what will be the maximum possible performance I would get for a given number of threads? Let's say I would run 10 threads. What will be the maximum performance? Something like that. So we'll ask such questions and answer them. That I will keep it for a little while, because initially I want you to get used to writing parallel codes, and and later on we can ask this question.
All right, thank you.
Yeah, thank you. Any other questions, anybody?
So I had a doubt in tutorial 1. In
Yeah.
that, in the third part, can you explain the coding that you did of GNU plot? I mean .gnu file. I did not understand that.
Okay, sure. I can do that. Hold on, just a minute. So this is tutorials 1, GNU plot. Okay, which one? Line plot, is it? You didn't understand line plot?
Yes, sir. Yes, sir. .gnu. Yeah.
Okay. So this is basically just a. So I mean, you can get help on the internet. There are a lot of tutorials, but the first one is basically setting the terminal type. You can basically setting it to some EPS, basically PostScript, and this is for setting the font and all. And set key is basically where, let's say you have drawn a line, you say a line is let's say reference data, another line is your results and things like that. So that is where the key will be. So it is basically setting at the bottom right and something, and then these two lines here are setting the Y label and the X label. Okay, and then size is again to do with the aspect ratio and the size of the graph that you're plotting. And ticks are basically your there are on the x-axis you have these uniform intervals, right? So just like on a ruler. So that is what the ticks will set. So you can also set whatever values you want, and then it is setting the output to this file. So once you run this thing, you will get a file called matrix product time.eps. That's where the output will be saved in EPS format, of course. Then this is the main command. Okay, so whatever I have set till now is not super important, but this is the one. So plot production dot prod.txt, that is the file name, and U is basically a shortcut for using. Okay, using 1:2. These are 1:2 are the columns, first column and second column. So you're plotting first column on the x-axis, second column on the y-axis. Hopefully there are 2 columns in prod.txt, and then W is a shortcut for width. Okay, and LP is a shortcut for lines points. So you want to draw connect these data with lines as well as with points, and the LT is for line thickness. These are all shortcuts, so you don't have to write. Line thickness is 1, and this is PT stands for point type. So for example, you want to have a square symbol or something like that, and point size is size of the symbol. For example, you want to have a small symbol or large symbol and so on. T stands for title. Okay, that's it.
Okay, sir. Okay, got it.
Yeah, it's always easy to write with the shortcuts because needless to say, we'll make a lot of spelling mistakes and it will not be good. So you always use L, L, T, all those things. Fine.
Yes, sir.
Is there any advantage for the critical directive given that reduction actually does away with the disadvantages of critical?
Yeah, so critical, so see, I mean, essentially reduction will expand internally to critical section only, right? So this is more fundamental as such.
Okay.
Yeah, so reduction is a little more specific. For example, only if you have an operator, if you want to do some addition, some multiplication and so on, it would do. For example, sometimes you don't have any reduction as such, you cannot use this at those times, right? Because reduction always asks for some operator here. For example, let's say critical could be where you have to read sequentially from the user one after the other some data, right? You have an array, and in those sections you can just open as a critical section, it will be executed in serial.
Okay.
Yeah. I mean, certainly, see, we are not comparing. So we are not comparing some of the directives with the other ones. Okay, but they all have their own advantages. But most of them, some of the thing is, you can write this parallel program in several number of ways given one particular programming language. Only thing is that some of them actually make use of the other quantities internally, so that you can build on much easier way to deal with certain operations. That's the only thing.
Okay, thank you.
Yeah. So have you guys done the tutorial 1? You were able to run it and then get some results? Are you guys able to run tutorial 1?
Yes, sir.
Yeah, okay. Tutorial 2 also, as as we discussed, you can run it on your laptops for now. That's what I'm also doing. So if you have a 2-core or a quad-core machine or something, it'll definitely run. We are not looking for performance anyway. Okay, fine. Yeah, so the third one, fine. So yeah. Okay, so the tutorial 2 also you can work on once you're done with the first one. And I haven't kind of paid a lot of attention to Fortran code as such because I'm kind of following the C one. I would like to also do some Fortran, kind of mix and match sometime. But I would like to know if anybody is actually working with Fortran codes, or is all of them, if all of you are only working with C, then I don't have to go into Fortran as such. But most of the codes that you will be working, many of you may be written in Fortran. So that's the reason I would like to draw parallels. But it will be very similar. You have one-to-one correspondence between the functions and the directives and things. Is anybody working with Fortran as such for this course?
Yeah, I work with Fortran, but if you can just explain it in C, it's fine. I can find the corresponding Fortran versions, and if I have an issue, I can surely ask.
Sure, you can always drop an email. You just put it on the discussion forum. I'll put it. I will try to bring in some Fortran, flavor to the course. I mean, every time I do it with C, so I'll do it with Fortran as well. It's not difficult. Yeah. And sometimes maybe I'll do the Fortran and then put C, as the backup, so that it's kind of balanced. Maybe. Yeah. Fine. Okay, that's good to know. So that I'm not teaching something that you say, okay, I don't work in Fortran, so I don't have to listen. Okay. Fine. All right. Thank you. Yeah, please use the discussion forum. Okay, post whatever questions you want, and I think, the TA Sakti also replied, and whoever, other students are also replying, so it will be active there. And we will also, reply as soon as we get a chance to answer.
And sir, what about the VPN access?
I think Professor Rupesh has just sent it over to the net admin people, so they will work on it and probably will give you the VPN access soon.
Okay,
Probably
sir.
in a day or 2 days, maybe by Monday or Tuesday they will give you, I guess.
What is the quiz 1 dates? I know it's probably too early, but still want to know.
Quiz 1, I'm guessing it will be sometime in first week of March, maybe first or second week of March. I have to open the academic calendar actually.
Okay. Yeah, I checked in the calendar, but I don't.
Was there a
dates
date?
for quiz. No, I don't think the dates for quiz 1, but I should recheck actually.
Yeah, but that should be okay. I mean, it will be sometime in March. So the date can be flexible because it's online, so it can be flexible. We will probably have it in one of our lecture times or something like that, so that everybody is free.
Okay. Yeah.
Yeah. Yeah, but the syllabus will be tentatively the OpenMP and the numerical methods with OpenMP, and the introduction. So that will be like, 5 weeks. So we'll have one after that.
Good. Thank you.
Yeah. Are the code font, all those things okay in the video lectures? You're able to, they are kind of legible? Okay, fine. Okay. Fine, okay. Yeah, if you feel any issue, just, drop us an email or something. I'll try to modify accordingly. Fine.
There's a question in the chat box.
Oh, okay. Work sharing region may not be closely nested inside of work sharing, critical ordered master explicit task or task region. What exactly does this mean? I got it when trying to OpenMP for inside OMP parallel, as you mentioned. I have to see the code maybe. Yeah, I have to see what is the code you have written. So maybe can you drop me an email or something? Or can you post it on the discussion forum, that particular thing? Yeah, you can do it here, but yeah, sure, no problem. But I don't know if I'll be able to fix it immediately. Okay, yeah, you can post it. So you have OpenMP parallel for num threads. Int I equal to 0, I less than 4i plus plus. That's the thing, right? So you have hash pragma. So you have for inside for. You would not have two fors. That is the thing. It's probably is doing not correct, isn't it? You would not have a for on the top, no. So you want to parallelize. So this will be 4 times 2. Is it 8 threads you want to run or something? Or is it just, no, you would not have the parallel for the first for, isn't it? I mean, you can do it, that's not an issue. But then if that is the so, then it should have another parallel for the second one also, isn't it?
Sir, so over the second for, where it won't be parallel for.
Sorry, you want parallel for the second one, is it?
That's what I was trying to do. I was trying to get the slave threads from the first parallel for to fork again.
Ah, okay.
So,
then you can also put parallel for the second one also, isn't it?
I tried that, then it runs the whole thing serially.
Oh, okay.
Then it prints 0 all the time.
Okay. OMP get thread num. It should not be the case.
So Venu, how did you figure out that it is running sequentially?
Okay, so the second parallel for has 2 threads, and my processor has 8 cores, 8 logical cores,
Mhm.
and it's 0 all the time.
It's printing 0 all the time. Oh, you mean that it is not creating the threads for the inner parallel for at all?
That or the whole thing is running serial. Most likely it's the what you mentioned. It's creating 4 parallel threads earlier, then those are not getting forked again.
No, if you want to fork again, then you have to have another parallel for, isn't it?
I had tried it with the parallel for. That's when I got all the zeros. This code does not compile. This code gives that error.
Yeah. So because this is not correct, because if this code has to compile, then you have to remove parallel. You have to remove for the first thread, or something like that. Yeah.
Yeah. So to add to what Kameshwar is saying, the nested parallel fors are allowed. That is not a problem. But I'm concerned about why it is not parallelizing. Maybe we'll try this out and
Yeah, we can try it. Can you just send us this snippet as an email or something? Or just post it on discussion forum. That is a better place because everybody will get to try it.
Sir, in this code, I think we have to set the number of threads up higher, and then I think we can execute this. I mean, it will run without error.
You have given no num threads 4. You have given, right?
Yeah, but that is for just outer for loop. In general, for entire this whole block, I think we have to set.
Okay. What do you mean by that? That's what. So you have either, I mean, you have an environment variable which you can set, or you can even set it explicitly with this thread count, isn't it? The num threads option should do that.
Yes, like using num thread option, we can set the number of threads for this entire block, and
Okay.
that and then hash pragma mp parallel for will we can place it at both the loops, and then
Right.
I think it will work.
Yes.
So
Yes.
we are fixing the number of threads, and then we are telling both the for loops to run parallelly based on that number of threads.
Yeah. The number of threads, it should also be uncommented in the second one as well. The inner one also.
Yeah, that is true.
Yeah, and then you may actually get dual numbers, like there will be 2 zeros, 2 ones, and so on, I guess, right? Because I don't think it will give in terms of 0 to 7. It will probably give you 2 sets, 2 repeated thread counts, maybe.
Yeah, I think that might be the case.
Yeah. Okay. Okay, any other questions, anybody? Yeah, Venu, can you please post all these links as well as the code on discussion forum? At least the code, so that everybody can take a look. Yeah, okay, thank you. No, you can do it later. Need not be now. You can do it just anytime later in the evening or tomorrow. That's fine. Okay, any other questions, anybody? Okay, if no questions, we'll call it a day. We also reached our 550 point. Maybe we'll call it a day, and then we will meet next week at 5 p.m. And before that, we will have anyway our lectures posted on from Tuesday onwards. Okay. All right. Okay, everyone. Thank you for joining, and have a good weekend.
Sir, one small thing.
Yeah. Go ahead, please.
For the recorded lectures, there's no attendance whatsoever, right? We don't even have to mark it as watched.
No, I will send an attendance for everything.
You will send as in how?
No, I'll probably create a, Moodle attendance or maybe Google Calendar attendance or something like that. Google Forms or something. Yeah, but it's up to you. I mean, if you don't want to join, that's fine. I don't know why you are asking that question.
No, I was not sure how you were planning to take attendance for the recorded lectures.
Oh,
Is
okay.
there-
Oh, you mean for recorded lectures? Okay, so, well, the thing is, see, I mean, I would like you to listen to it and then say that I have listened to it. You know, that's how I take it. I kind of trust you that you're listening to lectures and all.
Oh, okay.
Yeah, I'll just send out maybe a Google form or, you know, something on Moodle so that, you know, I keep track of at least, let's say if somebody drops in between, I would not know whether he's still in the course or, you know, have dropped or something like that. So for that sake, I would like to kind of collect some attendance and things like that. Fine?
Yes, yes.
Yeah. In fact, actually, I would not even track people. Say we would not even track people who have joined for live sessions also. So we will just send out one email, you know, saying, did you attend the live session? So even if you did not attend and you say I have attended, that is fine with me, no problem. Yeah. Okay. Anything else, anybody? All right. If there are no questions, then we'll call it a day. Thank you, everyone. Talk to you next week. Okay. Bye-bye.
Thank you, sir.
Thank you.